Να καλωσορίσουμε λοιπόν και από την πλευρά μας όλους τους συμμετέχοντες. Έχουμε ήδη τρέξει το session με το Lift και έχουμε προσθέσει πράγματα που θεωρούσαμε ότι θα είναι πολύ χρήσιμα. Αυτό λοιπόν που θα κάνουμε, sorry for the Greek guys, αυτό που θα κάνουμε λοιπόν σήμερα είναι να εγκαταστήσουμε από την αρχή from scratch ένα Nginx, να δουλέψει σαν reverse proxy μπροστά από ένα mock-up e-banking application, να δοκιμάσουμε μερικές απλές επιθέσεις, όποιος θέλει μπορεί να δοκιμάσει και κάτι πιο σύνθετο, και μετά σιγά σιγά να κάνουμε deploy πολιτικές WAF και να αρχίσουμε να κάνουμε block αυτές τις επιθέσεις, να βαθμίζουμε πολιτικές, να ενημερώνουμε πολιτικές, να ενεργοποιήσουμε threat campaign και θα φτάσουμε και μέχρι ενός σημείου που θα ακολουθήσουμε ένα CI/CD cycle κατευθείαν για deployment. Όπως θα πει και ο Liv, το υλικό του σημερινού σεμιναρίου καλύπτει περίπου το 140% του χρόνου, που σημαίνει ότι ούτως ή άλλως εξ αρχής έχουμε υπολογίσει να υπάρχει παραπάνω ύλη. Τα labs, τα virtual machines, τα VDIs θα είναι ανοιχτά για αρκετές ώρες μετά το session, οπότε όποιος θέλει μπορεί να συνεχίσει και να ολοκληρώσει και τα υπόλοιπα labs. Στο πλαίσιο αυτό το δικό μας θα προσπαθήσουμε να καλύψουμε όσο το δυνατόν περισσότερη ύλη γίνεται. So, Liv, I just explained that we have about 140% of the topics that we're going to cover today, and we're going to leave the virtual machines up and running for some hours afterwards, so everybody can finish the whole lab, the whole deployment guide.
Sure.
So I think, and I have explained briefly what we're going to see today. So I believe that the stage is yours now.
Thank you so much. Thank you. And thank you to all the attendees for taking time out of your busy schedules to spend some of it here with us today. Thanks so much for that. You should all have received email invitations to the UDF framework, our unified demo framework platform. Once you've logged in on that, you should likely be presented with a screen that looks a little bit like, let's see, if I share screen, things will be so much easier, I suppose. Share screen. There we go, and share. So it should look something similar to this. This button may say join or continue if you've already joined. There's a slight waiting period after we've kicked off the environments. So I suggest we start by doing that, and I'll go ahead and introduce and explain the workshop a little better once we've done that. So start by, if you haven't already done so, click the continue or join button, which should lead you to a page that looks very similar to this. The first thing you can do on this is to right-click on the lab guide and choose open in new tab. I've already done that. I have it here. You'll automatically land on class 5. That's not an error. That's exactly where we want to be. It's class 5 we will be covering today. Anyways, going back to this page here, it has two tabs, a documentation tab, which is the one we're on right now, and also a deployment tab. If you click the deployment tab, you should see something similar to this, although you'll likely see a loading icon here instead of the play button. So this will take about 5-7 minutes, something along those lines, for the environment to spin up. So let's just make sure that we've gotten past this page and into this one, so the environment can spin up while we're discussing what we will be doing here today. So cool. I can start by talking a little bit about the environment we're looking at. We don't really need to go into the subnet side of things, but under systems, we have an ELK server. We have a few Kubernetes nodes. I think there's a couple down here on the bottom as well. We have an App Protect in CentOS node, which is basically just a vanilla CentOS 7 installation. Right now, there is nothing on it. If we So I think it was already mentioned, we've created about 140% of content. There's no expectation that we will get through all of those 140%. We're aiming somewhere for the 100%. And for those of you that have time and inclination, you can continue going through the lab guide for the last bits. So we might or might not get to the CentOS bit. We'll see how that plays out, but we'll certainly cover the processes anyways. There's a Docker App Protect and a Docker repo, essentially our Docker host sitting here. We will be doing a lot of work on this particular instance. There's also a CI/CD server, and we'll be doing a lot of work on this particular instance as well. If there are any amongst you that are relatively unfamiliar with Linux environments, you shouldn't be worried. It is command line, but everything is well outlined in the lab guide, as well as I will be going through this with you guys as we progress. So there's no big learning curve threshold here. We should be fine. We have a GitLab container, which we will use to simulate some CI/CD tool chains kicking in. We have our Windows 10 container, which is our jump host. This one is where we will be doing most of our work from. And finally, our additional Kubernetes nodes. So we'll just let the environment spin up in the background for you guys, and I'll pop over to the lab guide and go through the first few pages of it. So it's this is the architecture that we're looking at from the beginning, right? So we are going through a big IP device which is sitting outside of this lab environment, but that one doesn't really matter for the purposes of this lab, because it just transparently forwards all of the requests into the relevant nodes. There is no protection going on here. There's no advanced stuff happening on this node for this particular workshop. So every request coming from us, the customer, will just be pushed forward to the relevant containers and virtual machines. What matters for us mainly is what sits in here. So we are going to build some Nginx Plus containers. We're going to build first and foremost an Ingress controller, and then we're going to build several Docker images of Nginx Plus with App Protect with different methods, just to illustrate how the procedures are and how they differ. We're going to spin up an application. That's one of the first steps we'll do. With my very limited understanding of the Greek language, I think I noted that Nikos was mentioning that it's a mock-up banking application. We'll look at the architecture of that momentarily. So we'll spin that up in a Kubernetes environment. It consists of 4 basic services. We'll see that in practice momentarily. So this is the Arcadia Finance application, the way it's supposed to look in our scenario. It consists of, as I said, 4 main services. The way we're going to spin it up is by utilizing Kubernetes tools, which in turn is using backend tools to spin them up. We don't really need to understand all of that. That's not the purpose of this workshop, but I'll briefly explain what we're doing as we're going through it. So the components of the Arcadia Finance application is essentially these 4 microservices. You have the main application, which will respond to simply /, and that's the main web application you see in front of you as the total interface. There's a backend which responds to /files, and then there are 2 services for money transfer and refer a friend, respectively. The main app and the files is, well, doesn't really have a visible component outside of being the main application. The 2 refer a friend and transfer money services are visible here, here, and here. So if they weren't deployed, you'd see a coming soon message, which you may run across when you deploy this and deploy the Ingress controller yourself, because the web browser, Edge in our case in the jump post, does cache locally, right? So we might have to refresh the page a few times to see the actual change in question, but we'll cross that bridge when we get to it. Yeah, so effectively, the reasoning for this is this application can be used to showcase how it looks when you're deploying microservices in real time. We have another lab that does exactly that. That's not the focus of this one, though. So if the microservices for transfer money and refer a friend are not deployed, but the main app and files are, then you'll see the full application, but not these two modules. Yeah, so let's see here. Okay, then we're getting to the deploy and publish element of this, and that means we're getting to the stage where we need green arrows for the majority of these components. I don't know if we're quite there yet. We could potentially. Do we have? Hold on, let me see here. Isn't there some kind of raise hand function in Zoom if memory serves? Where are we there? Okay. Yeah, so chats. Yeah, so we're such a manageable number of attendees. Could you guys check whether or not your systems are running, or if they're still in a booting stage? If there are still systems that are booting, please alert me. Okay, excellent. I'm getting some feedback in the chat already. Yeah, the speed of which this happens can differ slightly between. All of this is running in AWS, and right now we're spinning up in the vicinity of 400 systems, which isn't, of course, excessive in terms of an AWS platform, but it can nonetheless differ somewhat in speed of spinning it up for the different attendees, but we should be closing in. So I see somewhere here. Thanos, can you re-verify? Are you still booting, or is it running for you now? Excellent. Okay, it looks like we're getting there, and we're gonna take this at a nice and leisurely pace, so there would be ample time to catch up. The lab guide is incredibly detailed. It shows you very, very clearly, step by step, what to do. So if you guys promise not to tell my boss, I'm largely superfluous to requirements here. I'm not really necessary, but I'll stay with you anyways because I have a paycheck to justify. So moving into the lab guide in step 1, deploying and publish the Arcadia finance application in Kubernetes. First, we get a view of the YAML file that we're going to deploy. Those of you familiar with Kubernetes, it's largely YAML it operates with. You feed it a YAML file that describes an environment or a service or a pod, however large or small that YAML file is. And then we use a text-based configuration tool, kubectl, to apply that YAML file. Then Kubernetes will wave its magic wand and take care of everything, create the environment that you have outlined and specified in the YAML file. For this YAML file, you don't need to copy or paste anything here. We've already put it in place inside the environment that you're going to be using. In regards to that, the environment that you're going to be using, as I mentioned earlier, we're going to access everything through the Windows 10 jump host. That's to make sure that there's no firewall issues and everybody has the same starting point, so to speak. So the way to access that is just click the access link for the Windows 10 node. You'll be presented with a list of resolutions. Just pick the one that you prefer to work with. If you have a full HD screen and you want to work in full screen, then 1920 by 1080 is fine. If you want to work in a windowed mode, then choose a resolution smaller than what you have. If you have a screen with a resolution larger than 1920 to 1080, you'll end up working in a windowed environment, but honestly, that's how I prefer it, so I'm not complaining. Anyways, when you click the link, you'll automatically download an RDP settings file. You'll likely see it pop up in the bottom bar of your browser, depending on what browser you're using. Just go ahead and open that RDP file. It should kickstart your RDP client. Answer yes to any, are you sure you want to connect to this system kind of a deals. And the credentials you want to use to access it should also be outlined in the lab guide here. Yes, it is. So you RDP by default will assume that you want to log in as administrator. Just click change user, and the username is user and the password is also user. So this is a super secure system, obviously. My apologies. So yeah, just go ahead and connect to the RDP session. Once you have, you should be presented with a screen looking awfully similar to this. I'll give you guys a second to get there. So yeah, once we're in this session, we're going to be using. I'm getting a little distracted here. There's a bird trying to get through my window here. Unusual. Anyways, once we're in the RDP session, one of the tools we're going to be using predominantly is the terminal in the tool. Windows has a rather nice new-ish terminal called, well, inventively Terminal. Which is just a modernization of the command prompt, essentially. So you get a cleaner interface with the tabbed browser, tabbed terminal, and so on and so forth. So we're going to go ahead and open that fella. That's our terminal. So I'm just going to go ahead and maximize it. So we have some space. And you can tell by the Windows prompt here, or rather by the terminal prompt here, that I am in my Windows system. So I'm now locally on the Windows 10 jump host. We're going to go ahead and SSH into a few systems. First, we're going to start, if I pop back over to my, my lab guide, we're going to SSH to Ubuntu, which is the username, at 10.1.1.8. This equates to the CI/CD server. There's going to be several statements throughout the lab guide that we're going to SSH to a system. Please make sure, either by the IP address or by the reference to what server it's talking of, that you're working on the right system. You wouldn't really be able to break anything because the commands we're going to be running on the CI/CD server wouldn't run on the Docker host, and the commands we will be running on the Docker host wouldn't run on the CI/CD server. But just to avoid confusion, make sure that you observe what system you actually are intended to go to. So I'm just going to go ahead and copy this SSH command because, as has been proven so many times before, I'm completely useless when it comes to typing. And I'm going to pop back over to my RDP session, and I'm simply going to paste that into the terminal. There we go. And when I press enter, I should get into that system automatically. And you see the prompt has changed. I'm now Ubuntu at Ubuntu. Sadly, the server name was never changed when the lab was created. We are now in the CI/CD server. So here's what I recommend to all of you when you're using the terminal here. Since the Docker host we will be working with a little bit later in the lab is also called Ubuntu, to make sure that you know which system is which, go up to the tab on the top. And simply right-click the tab and choose Rename Tab, and put in CI/CD or CI/CD Server as the name for the tab. It'll give you a clear indication of what system you're in, like so. because it would be very, very difficult to visually separate the two systems from each other when we get to that point in the lab. Excellent. So we're now in the system. I'm simply going to verify that I'm in the right working directory. The lab guide suggests we should be in /home/Ubuntu, which should be the default landing directory you're arriving at when you SSH into it. But you can use the command pwd to see what the current working directory is. And indeed, I am in the right one, and so should you guys be. When we see the next step in the lab guide, we see that it wants us to run, as we talked about, a kubectl apply, and we're feeding the kubectl apply command a file, specifically the all apps YAML file, which exists on the system that we're currently on. Are you guys not seeing my screen? It claims I'm sharing screen, but I'm getting feedback in the chat that some may not. What's the status? Are you guys seeing my screen or not? Yeah, well, my webcam is running, but
the documentation. I don't see the cell. I see the documentation right now.
Yeah, you see the documentation right now. Do you see the command prompt say now?
Now, yes.
Now, yes. Yeah, okay. So I am sharing the screen. Why are some people not seeing the screen? I'm getting feedback from a couple of users that they're not seeing the screen. Let me turn off my camera and see if that helps for you guys. Let's see here, stop video. Did that help? Are you guys... Okay, that looks like it's changed for some users. Yeah, okay, fine. We'll just keep my camera off. I'm not nearly pretty enough for that to make any difference whatsoever. So we'll just go ahead and run it like this. Okay, so the command... yeah, okay, cool. It seems to work for everyone now. The command that we were getting to from the lab guide is step 3 here. So it wants us to run the kubectl apply and provide it with the file, the -f and the path for the all apps YAML file. So we're simply going to go ahead and copy this. If you feel very adventurous and skilled on a keyboard, feel free to just type it out. I'm not nearly that adventurous, so I'm just going to copy it. I'm going to pop back over to my RDP session. To my RDP session. There we go. And I'm going to paste that command into the terminal. So now that I run this, and this should just only take a couple of seconds, it will go ahead and spin up the pods effectively that we need for the Arcadia Finance application. So there we go. We see it created the backend, the main, and the app2 and the app3. So all of these are now created. We can actually go in and verify that. Still sticking around in the RDP session, we can open the Edge browser. So it's down here on the menu bar, the colored wheel or whatever you want to call it. The somewhat inspired by an early Firefox logo, I suppose we can call it. Anyways, so it'll open up with the previous tabs, just close out the restore pages bit. And I think it's actually the Kubernetes dashboard it's trying to open on the first tab, if memory serves. It's claiming our connection isn't private, and it's doing that, of course, because all of the certificates are self-signed. So you can simply go ahead and click advanced and continue. And if I'm right, yeah, it's the Kubernetes dashboard. As for the authentication mechanism here, you can simply click skip. We're not going to do anything in the Kubernetes dashboard that requires any form of elevation. Okay. I'm apparently logged in several times because somebody answered yes to all panelists now with my name, and it wasn't me. Funny. Anyways, you can simply skip that. We're not going to require any elevated access in the Kubernetes dashboard. We're simply going to verify that indeed the deployments that we spun up now with a kubectl command are here. We see the pods as well up in our running state, preferably. So that's all very well and good. We have a visible representation for that. What we wanted Kubernetes to do has indeed happened. Always good. Now, it's important to note that we've only done half the job now, because we have indeed spun up the Arcadia Finance application, but we haven't made it accessible yet. The reason for that is we haven't defined an ingress controller for the application and how it should route requests and so on and so forth. We could have done that in one and the same operation. We could have had that done in the same YAML file, but for the purposes of the lab, it makes more sense to split them out so we can see the two steps in separation. So if we jump back over to our lab guide real quick, we'll see that we've done the last steps on the current, which is class 5 module 1 lab 3. What we can go ahead and do now is click next, because we've verified these bits. That's all that we need there. Next thing we're going to do is indeed push up the ingress controller with a fancy schmancy Nginx Plus ingress controller nonetheless. The good news again is we've already prepared the YAML files for you guys, so it's it should be easy peasy and straight surfing to get it done. Again, the first step is to SSH to the CI/CD server. We should still be there in the RDP session, so we're all still good to go. It's the same one we were working on just now. So it wants us to run a second kubectl apply command. This time we're feeding it another YAML file, full ingress arcadia.yaml. So I'm going to go ahead and copy this. And I'm going to pop on over to my RDP session, back into the terminal in the back side of things here. And I'm going to paste in the command that I just copied. And I'm simply going to run that. Again, this should be pretty fast. It should only be a few seconds. And what you want to see, you may note that there's a few warnings popping up. You can disregard them. They're expected. It's just a matter of some annotations that will be deprecated in a later release of Kubernetes. It's always the case. Kubernetes is an organism. It's growing and living, and it's changing over time. So this is the world we live in. What you want to see is ingress.extensions/Arcadia ingress created at the bottom line. If you're seeing that, you're all good to go. And we can actually verify that as well by popping over back into our Edge browser. And we should now see our replica sets. There we go. Under ingresses, we should now see the Arcadia ingress running. So I see it's been up for 47 seconds. Cool. That means we've now not only spun up the entire application consisting of the 4 microservices, but we've also created an ingress controller, making sure that it's accessible. So we can now verify that in the browser by utilizing one of the handy bookmarks we have on the top here. So the one we want to use is the Arcadia Kubernetes, or K8s. So I'm just going to right click on that and choose open in new tab. Should open back here. There we go. And there it is. This is our Arcadia Finance application. Now you can go ahead and click login here to see the application. It's the back end of it. If you just click in the username field, it should reveal cached credentials for a Matt fella. So let's just use them and log ourselves in. And there we have our application that we just spun up and created an ingress controller for. You should see that the invite your friends is working and the transfer money and send money to is working. If you have a coming soon element in any of those places, feel free to go ahead and reload the page. I think it's hold down Shift and F5 or Shift and click the reload in Edge if memory serves. and you should see it updated. You're probably just looking at cached information at that stage. So excellent. We've now completed step 2. If we go back to our lab guide, we've completed step 2. We've published the Arcadia app through the Nginx Plus Ingress Controller on the back of the YAML file. For those of you particularly keen on what the YAML file contains, you could either simply cat it or print it to screen directly in the terminal, or you can have a look at an excerpt of it here in the lab guide itself. Anyways, we're going to progress with haste to the next step. So we're now progressing into module 2. While we have created, or rather spun up our application, and we have indeed made it accessible through a Kubernetes Ingress Controller, we have not protected it. So right now, the application is just publicly accessible with 0 protection layers in front of it. And that, of course, is the principal focus of this lab. We want to protect it. We want to make sure that we can sleep a little easier at night knowing that someone is taking care of our application. Because honestly, there is no such thing as a completely secure application. Code is complicated, and coding for security has been a growing trend over the last 10-15 years, but it'll never get there, because with the complexity of code in massive applications these days, even if they're segmented into microservices, attack vectors and bugs are going to happen. That's just a reality we have to live with. So we need to have something that can help us protect against attack vectors. So we're going to go ahead and do that and protect our application with Nginx App Protect in Docker first and foremost. The procedure wouldn't be very different for any other type of deployment, but this is the way we're going to look at it first, because it ties so neatly in with automation and orchestration through, well, Kubernetes for one, but also through typical CI/CD tools like GitLab and Ansible and whatever you want to use. So let's start. We're going to create 3 Docker images. Let's start with the first one. I'm going to click next here. So we're going to build our first Nginx App Protect Docker image. It's very, very simple. Please note that we're now going to SSH to a different system, namely the Docker App Protect and Docker Repo VM. For those with good memories, you'll remember that it was .8 for the previous one. We're now going to .12. So I'm going to copy out this command, the SSH command, to save myself some typing. I'm going to pop back over to my RDP session and go to my terminal. Oh, sorry. There we go. And yeah, okay. So, and I'm simply gonna paste the command in. Actually, hold on a second. Give me a second. Okay, I'm not going to do that. For those of you that already did, you would have ended up in this scenario. Okay, excellent. So it wouldn't have gone through. Beautiful. What I am going to do instead is I'm going to open myself a second tab. And you see that the prompt is back to being on my Windows 10 computer, the jump host. And I'm going to paste it here instead. That makes an awful lot more sense. And now I'm in the Ubuntu, which, as you can tell, is awfully similar to here. So make sure that you're in the newly created tab. And I'm going to go ahead and right-click that and rename it in haste. And I'm simply going to call it Docker. That should remind me what I'm dealing with here. Cool. So what we're going to do now is we're going to build a Docker container. I assume that many of you will be well familiar with Docker. For those of you that are not, let's go ahead and have a quick look at the lab guide here again. So we're going to skip a couple of commands just to look at something, and then we're going to come back and do it momentarily. So Docker build, which is what we're asked to do in the lab guide, is a command for Docker to build a Docker image, which is the baseline for a container, based on a Docker file. What you're seeing here is a Docker file, and it's simply a linear structure of instructions for Docker to execute one or more build steps. So what we're saying here is we're going to base ourselves from an existing container image, specifically CentOS, with a tag of 7.4.1708. Docker will then pull that image if it doesn't have it in cache. It'll spin up a temporary container based on that image, and it will start running these commands into that temporary container. So the first thing that happens is we copy in our trial certs, and then we're going to install some prerequisites, wget, CA certificates, equal release, and then we're going to also extend the repository list with the repository for Nginx Plus, and then we're going to install Nginx App Protect. You may note that we're not, in fact, installing Nginx Plus anywhere here. That's because the package manager takes care of it for us. The App Protect package has Nginx Plus listed as a prerequisite, so when we yum install App Protect, it'll install Nginx Plus beneath it automatically. Assuming, of course, that we have have valid certificates and keys and access to the repository. Then we're doing some simple housekeeping here. We're just forwarding the access and error log to the Docker log collector, so we can see the logs from outside of the container. It's not strictly speaking a necessary step, but it's convenient for us to be able to see things. Then we're copying in some files from the Docker host, namely an Nginx configuration, a log default.json, which the name reveals is a log format that's going to be used in the config. And we're copying it into the relevant location. We're also copying in a file called entrypoint.sh to root, and the entrypoint.sh is a vital file for the container because that, as this command here as the final step indicates, is going to be the starting command. When you run a container based off this image, it's going to do whatever is in the entrypoint.sh. Since this is an Nginx Plus container with App Protect, the entrypoint.sh will include a reference to Nginx, spinning up that as the base service of the container. Anyways, that was just a brief explanation of what the Docker file contains. So we're going to pop back to step 2 here, and we're going to run the Docker build command. Much like the kubectl apply, we're going to feed it a file. If the file was simply called Docker file with capital D and resided in the working directory we're in, we wouldn't have to point towards a file. Which, by the way, we're probably not doing in this one. Keep in note that there's a final dot here indicating that we're working out from the current working directory. Otherwise, we would have to specify a path in this place. We're in the build command, we're adding a -t flag, meaning we want to tag the resulting container image with a name, which is App Protect, and a signature, which is no-sig here, standing for, a tag, no-sig, which stands for no signature. So the format in Docker naming conventions is name::tag. And we will end up with App Protect no-sig for this particular build. I'm going to copy that command, and I'm going to step back over to my RDP session in my terminal, making sure that I'm in the Docker virtual machine. And I'm simply going to paste my command here. This will take a couple of minutes. What it's doing right now is it's going through the Docker file that we were just observing, and first it pulled the CentOS image, then it copied the commands, it ran and whatnot. So it's going just step by step through the Docker file that we were just looking at. It'll typically take about 2 to 3 minutes to run through this. It's relatively fast. You can use this time for questions if there's anything on what we've gone through so far. I'm sure most of you, if not all of you, would agree that even if you haven't been exposed to many of the tools here, like Docker and Kubernetes and whatnot, this is pretty straightforward stuff. It's relatively easy to get a comprehension of what's going on, even if you're new to it. Did I hear somebody unmuting themselves? Oh, Dylan, welcome. How are you, sir?
Thanks, and you?
Good.
Everything is okay?
So far, I believe, yeah. I haven't destroyed anything yet.
Great.
I may have destroyed, well, not destroyed, but I may have damaged some people's will to live, but I haven't done anything permanent yet. We see here in my particular command prompt that it has completed for me. What you want to see as the final line is successfully tagged App Protect NoSig, which is what we were looking for. Once it has completed, and this should take relatively close to the same amount of time for each and every one of you, because all that defines the time it takes is the speed of which it can download the binaries from the repositories. And considering that we're all sitting on systems running out of one and the same AWS availability zone, I'd say it's likely we have roughly the same bandwidth available. To verify that we did indeed successfully build our image, we can simply run Docker images to get a list of the images that exists in our local registry. And you'll see at the very first line, we have our App Protect with the tag of NoSig. It'll have an image ID, and this is actually just part of the image ID, but nonetheless, it was created about a minute ago, and it's 599 megabytes in my measurement. Excellent. So we have an image created now that we can spin up one or more containers based off. Let's have a quick look and see what containers, if any, we have running at the moment. We can do that using Docker PS. And we see there are indeed 2 containers running at the moment. These are both just local registry containers that we're using for the purposes of storing container images that we're creating, like the one that we just created. So the bottom one here, registry 2.7, is Docker's own registry container, which contains our Docker images. And the one up top here is simply a web-based user interface for said registry. We're actually not going to touch upon the user interface. There's a couple of places in the lab guide where you can. We're not going to bother with it for our lab today. Cool. So we know that we have a Docker image. We know that it isn't currently running as a container. So what do we need to do to make that happen? Well, if we pop back over to our lab guide and we go down past the Docker file, we've already checked that the Docker image is available. Now, the lab guide suggests that we do a Docker run command. For those of you unfamiliar with Docker, Docker run simply takes a container image and spins up a new fresh container based off of that image. I'll explain in detail what the command does once I've copied it and pasted it into my terminal. So I'll go ahead and copy it here first and foremost, and I'm going to pop back over to my RDP session in the terminal. And I'm going to paste in the link, or rather the command. So, yeah, just give a couple of seconds for people to catch up. Okay, so the Docker run command, first we're providing it some flags. The D specifically means that we're going to run this command in a detached mode, which means it'll run as we won't step directly into the container. We'll just start the container and let it run in the background. We're providing it with a name, not a necessary step, but certainly a suggested step. And we're also setting up port forwarding. So we're going to listen on port 80 on the Docker host and forward all communications on that port into port 80 inside the container. We're mounting a volume with a -v. From the host, we're looking at /home/ubuntu/nginx.conf. So we're not even mounting a directory, we're mounting a specific file, which you can also do. the colon separate. So inside of the container, we're going to mount that file into /etc/nginx/nginx.conf, which is of course the default path for the main Nginx configuration file. Apologies. We're also specifying that we're going to run this container based on the App Protect :nosig container image, or Docker image if you prefer. This should be a very quick procedure. So once I press the enter key, it should only take like a second. And indeed, the default output is I get the full container ID of the container that's now running. If I run docker ps again, you'll see that we now have an App Protect container running. It's listening on port 80 on all interfaces, forwarding to 80 inside, and the name we gave it, and so on and so forth. So the container is up and running. That's perfect. That's exactly what we wanted. So now what we've done is we've created a protection tier for our application. We haven't really manually gone in and specified much in terms of what rules should be in place. We're using a default rule set. All of that is specified in the Nginx conf that we fed into it. But that's fine. One thing to keep in mind, though, is the way that we created it right now. We created this container with the signature base of the last time this container was updated in the particular repository it's pulled from. So it's very likely that we will be working on very old signatures at the moment. And we can verify that. We can check it pretty easily, because if you remember from when we looked at the Docker file, we set up some housekeeping rules. We were forwarding the logs from inside the container to the Docker log collector. So we can simply run docker log, what was the name? Docker log, it's plural, Docker logs, and the name is App Protect, like so. You can also copy this command from the lab guide, and in the lab guide it suggests -f at the end. Isn't really necessary for what we're doing, but all that means is follow. So we're currently following the log. If anything new arrived in the log, it'll automatically pop up on screen. Anyways, all we want to look at here is the attack signatures package. Revision datetime, yeah. So we're in 2019. So effectively, we're working on a very, very, very old set of signatures. That's of course not optimal, but it doesn't mean we're completely unprotected, because it will still protect against all the common attack vectors and whatnot. And we can prove that to ourselves. So we can pop into the Edge browser again. And we have a handy bookmark for, where is it? There we go. Arcadia NAP Docker. So I'm going to right click this fella and I'm going to open it in a new tab. There we go. So this is now me accessing the Arcadia Finance application through my newly created App Protect container. It's still using the previous Kubernetes-based, so the Kubernetes Ingress Controller. It's still going through the Ingress Controller, but it's now using the Ingress Controller as its upstream. The way that this lab is designed, this direct route of accessing it through the Kubernetes Ingress Controller directly from the outside is still available in a real-life production environment. You would obviously block access to the Ingress Controller directly and force traffic to go through the App Protect container. We haven't bothered with that for the purposes of the lab, because it's useful for us to be able to pop back and forth. Anyway, so this is going through the Docker container that we just ran. I'm just going to log in for good measure to see that that works, and so on and so forth, and it does indeed. And how can I tell that I'm actually protected? Well, I can run a pretty standard attack. I'm going to run a script injection attack. So I'm going to add a query string here by adding a question mark and a equals and a script tag. That should do the trick, like so. And yes, indeed, I'm immediately blocked. So I'm getting a rejection page. And those of you that may be familiar with the Big IP Advanced Web Application Firewall, or A.WAF, you would recognize this rejection page because it's exactly the same. And that is because it is exactly the same. Nginx App Protect is a software-based alternative to the Big IP Advanced Web Application Firewall. It's not more complicated than that. Why is that such a great thing? Well, it's a super great thing because while the Big IP A.WAF is a brilliant security tool, it has certain limitations in terms of architecture, in terms of where you can deploy it. By having a purely software-based alternative that is super small and super agile and based on something so proven as Nginx Plus, you can deploy it in places where you couldn't before, like what we did just now. We deployed effectively the A.WAF, or the Nginx alternative, the Nginx App Protect WAF, in a Docker container. That would have been impossible prior to this product's existence. It goes further as well, because you can, as a matter of fact, deploy Nginx App Protect directly on your Kubernetes Ingress Controller if you so choose. That's not always what you want, but sometimes it may be what you want. Let's say something simple that you want to keep your architecture small and compact, and you have a specific Ingress controller for a specific application or service or whatever. It may make sense for you to simply deploy Nginx App Protect on that Kubernetes Ingress controller rather than as a separate container or separate VM for that matter, thus introducing an extra hop count and all of these things. So sometimes you want to, sometimes you don't. The beauty is now you can choose exactly the solution that you want. Anyways, so yeah, we have indeed proven our App Protect container, but we're still quite wary because we know for a fact that we're operating off of 2-year-old signatures, and that's no good for us. So we're going to go ahead and fix that problem. Let's step back into the lab guide. We've done the whole testing of it bit, so let's just go ahead and click next. Now we're going to create the second of our 3 Docker images. This time we're going to use the latest WAF signatures. You may ask, why didn't we do that the first time around? Well, the reason is very simply that we wanted to illustrate the difference. And that there is next to no difference in the creation. So what we're aiming to do in this step 4 is we're going to create a new Docker image, a fresh Docker image that carries the updated signatures. And the first thing we're presented with is a view of the Docker file that we're going to use. This Docker file only differs from the previous one in 2 aspects. In the repository part, we're also adding a repository for the security updates repository. And in the installation part, in addition to installing App Protect, which we did in the previous run as well, we're also installing App Protect attack signatures. So those 2 things are the only differences between this Docker file and the previous one. So yeah. Let's go ahead and run this particular build. So again, it wants us to go to the Docker repo virtual machine. We should already be there. So I'm just going to go ahead and copy out the Docker build command, again, being observant of the final dot indicating the current directory as the path. I'll copy that. And then I'm going to pop back over into my RDP session, into my terminal. Oh, come on. Okay, so I'm still in follow mode on the log files here, so I'm just going to press Control-C to exit out of that. Yeah, I'm back to my prompt here. Clear, like so. And I'm just going to paste in the command I copied from the... actually, let me do this first. So when I look at the files in my current directory, I see that I have a Docker file that's simply called Docker file. And I have a number of Docker files that have an extension to their name as well. The command we ran first we didn't specify a -f. We're going to do that now. When we didn't specify a -f, it went in the current directory, which we indicated by the dot there, and looked for a file named exactly Docker file with exactly a capital D. So just like so. And it found this file and it used that as its Docker file. This time around in the command, we are specifying a -f and we're pointing this particular build towards a Dockerfile -sig. So this file here, and that's the file we were looking at just now in the lab guide. This is the one that contains the signatures repository as well as a reference to the signatures in the installation. And you'll notice that we've changed the tag a little bit. We're still going to name it App Protect, but we're changing the tag to be 2020-03-16. That's obviously a date. It's obviously not today's date. You can change that if you want to today's date. I recommend not doing it because then you have to change it in every subsequent reference to it as we go through the workshop. By leaving it like this, you can simply copy the command from the lab guide and not worry about it. The tag itself has no bearing on the content of the container. It's simply descriptive. We could use the tag orange juice if we preferred, and it would be just the same. All that matters is that we have a tag that's unique for this particular Docker image that we're creating. And since we're pulling today's signatures, if this was an automated procedure, which we will look at later on today, we would want the tag name here to be identical to the date timestamp of the signatures that were being pulled. So we'll look at that in detail when we get to it. We'll look at that in the CI/CD steps of the workshop. So let's go ahead and run this fella. It'll go through the same steps from before, so it'll take about the same time, 3 minutes or so. And it'll go ahead and grab these additional elements as well, the reference to the signatures repository, as well as installing the package for the signatures as well. Feel free to raise any questions if there's anything on the chat while we're waiting.
Leaf, since the Docker is deployed, maybe we should check if everybody is on the same page.
Sure, we can do that. If anybody feels that we need to slow down, feel free to state so in the chat. You can direct messages to panelists only if you prefer, so there's no issue with that. But essentially where we're looking to be right now is in our class 5 module 2 lab 2 specifically, and what we're doing now is doing the Docker build here of basing ourselves on the Docker file called dockerfile.sig. That's what's happening on the that's the last command that I issued. Do we have everybody with us so far? Or should I perhaps ask the question inverted? Are there anyone that needs us to slow down and wait for a second?
It looks like we're good.
Yeah, I think so, but we might as well wait for a couple of moments. We're actually making pretty decent time, so I am intending to give ourselves a few minutes break after the next. So we've created the second Docker container, container image out of 3 that I advertised. When we've gone through the steps for the third one, we're going to take a few minutes so we can refill our coffee cups and stuff like that. And that would also be a perfect spot to catch up if you've fallen a little bit behind. So that's coming up in, I don't know, 10, 15 minutes or so we'll be there. Cool. So in my scenario here, again, what I'm looking for here is the successfully tagged and the name and tag that I specified as the result of this Docker build command. So I feel I'm in pretty good shape right now. Does that mean I am now protected by updated signatures in my when I try to access the application through the App Protect route? No, it does not. And why doesn't it? Well, if I go and have a look at my Docker PS here, you'll see that I'm currently running my App Protect container based off of the previously created container image, right? If we look at our Docker images, and if I perhaps could learn how to type any day now, ladies and gentlemen, I promise I'm going to take a typing course. We see we have now 2 container images here. One with the no-sig tag, which was the first one we created, and one with the other, with the date tag, which is the one we just created now. You'll see when they were created, and you'll also see that they differ slightly in size, which is to be expected because the latest creation is exactly the same as the previous creation, but we're also adding the updated signature file. So we're expecting a size difference there. So how do we then go about making sure that we're protected with our new container? Well, it's actually very simple. We can pop back into the lab guide so you can see it described as well. All we need to do is to purge the existing container that's protecting us right now and replacing it by a new container based off of the image we just created. So we've built it here. We've done that part. Now what we want to do is we want to purge the existing container, and we can do that using this command, docker rm, and we're using -f to force it to happen. Normally you can't rm, which is remove a container image, a container if it's in a running state. When we add the -f, we will first stop it and then remove it in one and the same go. So let's go ahead and do that first. In my terminal, I'm going to paste in the command and I'm going to run that, and it responds with a name. If I now look again at my Docker PS, look at what's running, we see that there is no App Protect container running at the moment. We will fix that by popping over to our lab guide and copying out the Docker run command here. I'll explain it as I paste it into my RDP session here. So all that's happening here is we're doing essentially exactly the same all the way up to the end of the command, where we're just pointing it towards our new image rather than the previous one. Other than that, we're running exactly the same Docker run command. So let's go ahead and run that. Should only take a second. And there we go. If I now run Docker PS again, you will see that I do indeed have an App Protect container running, and it is indeed based off of the container image that we just created. So we should now have updated signature files for our App Protect container. And how can we verify that? Well, we can simply do docker logs app protect, like so. I did it without the -f, which means I won't have to Control-C out of it. So you can do whichever way you want. What you want to be seeing here is attack signatures package, revision datetime, and all of a sudden we have an updated revision datetime, which is in fact yesterday's date. So that's a little bit better than 2 years ago. Excellent. Now, we are now protected with an updated set of signatures. But we are not utilizing the threat campaigns, which we really would want to in this case. So we see that the threat campaigns package is an empty object. We would love to see that being populated and being used. So that's what the purpose of the third Docker image we're going to create for today is. We're going to go ahead and we're going to create the third image. And this time around, we're also going to instruct it to do the threat campaigns bits. So how do we do that? Well, if we pop back to our lab guide, next step, boom. So what we want to see is class 5, module 2, lab 3. We're now going to update the Docker image with a threat campaign package. And the procedure is very similar to what we just did for updating the signatures. We're going to create a new Docker image. That, of course, means we're going to make that based off of a new Docker file. So if we step down here a little bit, you'll see the new Docker file referenced. So what's new in here versus what we've already done? Well, it's mainly exactly the same. The only difference here is we're also adding the App Protect threat campaigns to the installation part of the Docker file. Other than that, it is identical to the previous ones. So let's go ahead and do exactly that. There's again a handy command here to copy out the Docker build command. And you see I'm now basing it off of the Docker file sig tc file. Keep in mind the period, the dot at the end of it. So I'm copying out that. And I'm gonna run it in my terminal. So I'm just gonna paste that in there. I'm making a new tag, which is now TC for threat campaign, and I'm basing it off of well, not new, but I'm basing it off of our full Docker file for the threat campaigns. There we go, and it'll take a couple of minutes. So a question came in through the chat while we're doing this. It's a good question. The question is, can you, and if so, how, limit the resources Docker container requires to run? And the answer is yes, absolutely you can. That's not really part of this training course, nor is it really part of an Nginx thing. This is purely a Docker question. But yes, there are flags that you can add to the Docker run command that that limits how many CPU cores it can access, how much memory it's allowed to utilize, and all of these things. And you certainly can do that. Simply Googling Docker run resource limits should likely, actually, let's just do that while we're waiting. I imagine that Docker run resource limits, I imagine that we would be getting something, runtime options with memory, CPU, and GPU, yeah. So this will go through what runtime options you have to contain the container, so to speak. These are obviously also things that can be instrumented through Kubernetes. So in the YAML file that you use to specify how this service should look, you can also tell Kubernetes that I want to have these limitations for the resulting Docker container, and it'll take care of that for you. So the answer to that question is absolutely possible. It's not really in the scope of this course, but this is where you find information about that. So there's another question. Let's just handle that right now as well. The App Protect pod, can it be paired with the community version of Nginx Ingress, or is Nginx Plus mandatory? Well, first, there's a couple of different versions of the community version of Nginx Ingress. We have one that's delivered directly from Nginx, and also the default Ingress controller that Kubernetes ships with is also in air quotes, community version of Nginx Ingress, although it's with their flavorings and their spices thrown into the mix. We have nothing to do with that other than we provide the base Nginx open source binaries, and they do what they want with them. The answer to the question, though, is no. Nginx App Protect is Nginx Plus specific. It requires several of the features from Nginx Plus, not to mention that security shouldn't really be an open source concern with the lack of supportability, indemnification, and all of these things. So yes, and App Protect is as it stands, requiring Nginx Plus. So a couple of things. Let me just quickly look. Evaluate false positives and disable any rules that cause them. You will be able to, I mean, the first thing you'd probably want to do when you deploy App Protect is to put it into monitoring mode rather than blocking mode, and have a look at the behavior of App Protect through the resulting logs. We'll look at that in a little bit, and then enable and disable rules as you see fit. And perhaps having different rules for different parts of the application and infrastructure for that matter. We'll look at that shortly, so we'll pop back to that. Let me just see, there's one more question. Since the WAF process is CPU heavy, if we don't place any limits, can it consume more resources than are virtually available in relation to Inspire? No, so you can never consume more than 100%, meaning that if the Docker host itself is limited to a certain percentage of the physical machine's resources, then any and all container images, including Nginx App Protect running inside of that Docker host, will be suffering from the same limitations. I'm using suffering slightly incorrectly here because it's by design, right? It's intended that way. Meaning that you don't have to put resource limitation flags on when you do the Docker run. But if you want to keep strict control over how much can this, that, and that container consume, then certainly it's advisable and a way to do that. Anyways, moving back to my RD.
Can I add something here for that?
Sure.
Certainly WAF is a heavy process, but I mean, limiting the resources, actually you are limiting the performance of your website. If you have a website that is capable of accessing 1,000 requests per second and you limit the WAF capabilities, then you will end up not being able to serve 1,000 requests per second. So I think you should leave the resources to the WAF so that the WAF can serve and can protect. And maybe you can limit the request per second on the Nginx Ingress Controller, how many requests you should handle.
Absolutely a valid comment, for sure. I can envision scenarios where putting resource limitation may be beneficial, but you have to be very, very wary of what was just said. You could very quickly end up in a scenario where you're essentially limiting access to your application in entirety. The scenarios where I envision it could be used is where you're seeing that there are different elements of what the container, or rather the overall pod, is doing that ends up being the limitation. Perhaps disk I/O is in fact what is causing the limitation, and you want to spread that across different storage systems. As such, you want to spread the load of the WAF component over several different containers that will log to different systems, for instance. You could do it that way, and by setting an artificial limitation on the resources, you could force the load balancer sitting in front of it to make intelligent decisions on where to throw the traffic and so on and so forth. So there are reasons for anything. I mean, utilizing options just because it is new or looks good isn't necessarily the way to go. I prefer, if it tastes good, then that's what I'm going to go for. But yeah, so all of these are options. The topic of when and where should I introduce resource limitation flags in Docker, it deserves its own class for sure. And honestly, I wouldn't be the one teaching it. Anyways, so I see there is an additional question in the chat. I'm going to look at that shortly. I'm just going to progress through this so we're not getting disconnected from what we have already done completely. So yes, what was the last step? Indeed, we were building the third Docker container image. So if we now do a Docker images, like so, we see that we now have 3 versions of it. We have the original NoSig, we have the recent one with the updated signatures, and we now have the TC. We also see that there is a difference in size between the 3 of them, indicating that they are indeed slightly different. Now we're going to have to do the same thing as we did recently, because when we look at Docker PS, we see that we are still running a protection image, but it is based off of the previous container image. So we want to update that with the current one that includes the threat campaign side of things. So how do we do that? Well, exactly the same way as we did the last time, and we have handily, readily available, copyable commands in our lab guide. So let's just step over there. We see we've run this one, and that's fine, and we've gone through that. So now we want to do these 2 again. We want to remove the current or completely purge the current App Protect container. I'm going to do that like so. And just to show you proof, if I do Docker PS, we see we have no container running. So I'm going to go back over into the lab guide, and I'm going to copy out the run command to run the updated the new container based off of the new container image. So I'm doing that here. You will notice that the command is exactly the same, with the exception of we're now basing it off of our newly created container image. So let's go ahead and do that. Should only take a second. Now it's worth keeping in mind that when we spin up these protection containers, when we spin up the App Protect containers, or an App Protect virtual machine or physical machine for that matter, it will take a little bit longer to start the Nginx process fully than it would if we weren't running Nginx App Protect on it. And the reason for that is the first thing that happens is that it compiles the rule sets that is defined. And making sure that they are super fast, or as fast as possible to trigger. And this goes back to what we were just talking about in terms of resources and whatnot. One thing that's worth mentioning is Nginx has had web application firewalls for many years. So Nginx App Protect is not our first foray into web application firewalling. We've had several before, most notably being the Nginx WAF, which is based on mod security, which has been hugely popular and used for a long time, and it's been around for years. Then what is the difference and the benefit from going with Nginx App Protect? Well, there are several. First and foremost, capability. The Big IP Advanced Web Application Firewall that Nginx App Protect inherits from is massively more capable than mod security ever would be. And mod security was never intended to be that comprehensive a security product as the Advanced WAF is. We're of course benefiting from the years and years of experience that F5 has in security product landscape, which is an experience that Nginx, in honesty, doesn't have in and of itself. Nginx has never been a security product. It was never intended as a security product per se. There are some security features in Nginx, such as rate limiting and connection limiting and these things. And we do have dynamic modules that can plug in, like the Nginx WAF. For that matter, Nginx App Protect is exactly that. It is a dynamic module that plugs directly into Nginx Plus. So yeah, we're gaining a lot of experience and a lot of execution knowledge in the landscape of security. But are there other benefits of going Nginx App Protect versus our traditional Nginx WAF, the mod security version? Yes, certainly. Performance. Even though every effort was made to make the Nginx WAF as performant as possible, including putting paid engineering resources on the floor alongside with Trustwave, co-developing the Nginx WAF with the authors of mod security, there was only so much we could do. We had to go to that step because mod security itself was designed as a module for Apache, and Apache, as I'm sure you know, is operating off of a kernel scheduled threaded model, whereas Nginx is in a much more modern non-blocking event loop. So just porting mod security turned out to be a performance disaster. So we effectively had to re-architecture mod security for Nginx, and that's how the Nginx WAF was born. Even so, even with all of those efforts undertaken, our testing indications show us that Nginx WAF, even though it's much more capable in terms of scope of execution and scope of features and whatnot, even with all of that, it runs about 20 times faster than the Nginx WAF. So that's a pretty big win right there. Anyways, I digress. We have removed the original, or rather the intermediate Docker container that we ran, and we have indeed run spun up on. No, have we done that? Yeah, I think we have. So Docker PS. Yes, indeed. And we have spun up a new App Protect container that is taking care of the protection based off of our third Docker image that includes the threat campaigns. The reason I mentioned the whole thing with we need to compile the rules and such for first and foremost is that it's not instantly up and running. It takes a few seconds for that to happen. So if we had ran this command, not Docker PS, sorry, Docker logs App Protect, like so. If we had ran that immediately after starting the container, chances are we would only have the first line of logs available to us. It would take a while before the rest of it came. Anyways, now that we have everything, we see that the attack signature package is indeed the updated one. We were expecting that because we've already seen that done. But we've now also populated the threat campaigns package with yeah, it's a couple of days since the last threat campaign package came out, but we are in fact running that now as well. I did promise you guys a break, and I will make good on that promise, but just as a last step before, actually, no, it makes perfect sense to take it right here and now when I think about it. So let's go ahead and take what time is it? Let me see there. How much time do we have left? It's fine. Okay, we can take a 10-minute break so people can take bio breaks or refill their coffee cups or whatever may be the case. Let's not make it 11 minutes though. Let's make sure that this time 10 minutes is 10 minutes, and I'll see you guys back at well, roughly 14:12. So yeah, let's go ahead and do that, and we will continue onwards from there. Thanks. So back again. Just while we were to give everybody a few seconds to settle in before we continue, there's a question about centralized management that's come in as well, stating that if you have a big IP deployment, then you can centrally manage the WAF rule sets and so on and so forth. How can you manage WAF deployed on each microservice node if you want to? Well, first off, let's make it clear that you can very well have a singular cluster, I should say, for high availability purposes, of Nginx App Protect sitting in front of your microservices infrastructure, similar to what you would do in a big IP scenario. You can go that architectural route if you want to. It could make, and often makes, more sense to separate out your WAF concerns into individual, let's call them micro WAFs, just to coin a term here and now. And that, of course, leads into this question: how can you then centrally manage that? Well, there are several ways. One that has existed since the beginning of Nginx App Protect and before that, for that matter, and will continue to exist, is to utilize existing DevOpsy structures within your deployment strategy. So using typical DevOpsy tools where you have perhaps an internal GitHub or something of that nature, where updated rule set files will be delivered from the teams that are responsible for it, and so on and so forth. Webhooks listening to these repositories will detect that update having happened, and automatically deploy that to the correct locations, building new container images automatically and spinning them up and so on and so forth. We're actually going to look at a simplified example of that momentarily. But Nginx App Protect is also finding its way into Nginx Controller, which is the centralized management and monitoring solution for Nginx Plus. So it's not feature by feature analogous to the Big IP solution as it stands right now, but it is getting new features in there with each and every release. And Nginx Controller, much like any other Nginx product, has an insanely tight release schedule, meaning that there are new versions of it coming out rather often, adding these new features onto it. So the idea is that ultimately you will have your centralized point and click interface, if you will, through Nginx Controller for managing your WAF side of things as well. Controller is fully fledged already in terms of ADC, or Application Delivery Controller, as well as API Gateway / API Management. So WAF is finding its way in there, as well as Service Mesh, as well as a few other surprises we have up our sleeve that will be coming out in due time. So that's the ideology there. The principle behind all of this isn't that, or rather the intent isn't that Nginx App Protect should fully, completely, and instantly replace every A.WAF deployment on planet Earth. That's not the strategy here. The strategy is to augment, not replace, meaning that we're operating under a mantra within F5, which is better together. So all of these acquisitions that F5 have done throughout the years have been to augment their portfolio, not to necessarily replace. The opportunities that arise from an Nginx App Protect strategy, in addition to or in contrast to an A.WAF strategy, is the automation and orchestration possibilities that become available to you that wouldn't have existed prior. There is some interaction with an orchestrated environment, specifically Kubernetes, within a Big IP deployment as well, with the container services and whatnot. But this goes so much further. This can automatically build container images on your behalf. It can orchestrate them however you choose. It can split rule sets into different segments, and so on and so forth. So there's a difference in architectural strategy, but it doesn't mean the one has to replace the other, or you have to pick one over the other. It very often ends up being a combination of strategies coming together to create an overarching strategy. With that in mind, let's progress. If we recall to just before the break, what we did was we replaced our non-threat campaign enabled WAF with our new threat campaign enabled WAF. So let's just do a Docker PS to prove that. And we see that our App Protect node is now indeed running with the threat campaign enabled Docker image as its base. So what we can do first and foremost is to simulate a few attacks that will be picked up by the threat campaign. And we've put together a solution for us to do that. We need to open Postman, which is this funky looking fella down here in the middle. And we can just start that. It'll take a few moments for Postman to start, so we can flip over to our lab guide in the meanwhile and make sure we're caught up there as well. We've done all of this. So yeah, simulate a threat campaign attack. So we're going into Postman, and we have a collection created already called NAP Threat Campaign. There are 2 attacks in that. We're gonna run both of them. You can run them once or multiple times. Now here in Postman, if I expand the NAP threat campaign, you'll see that there are 2 attacks here. There's a Jakarta and a Drupal attack. One get, one post. So I'm going to start with the Jakarta, and all I need to do to simulate the attack is to send it. and I'm expecting to see a blocking page down here, which is exactly what I'm seeing as the result. I'm going to send it a few more times just for good measure. It doesn't matter, one is enough. I'm just doing it to populate the logs a little bit. I'm also going to run the Drupal attack. And now it's a post, so it actually has a request body. You can go and have a look at it if you want to. I'm simply going to send it, and again, I'm expecting to see a blocking. Yeah, and I'm going to send it a few more times just to populate the logs. What we're going to do next is we're going to have a look at one of the many ways that we can visualize what's going on in our Nginx App Protect, specifically through Elk Kibana. So we're going to look at a Kibana dashboard, and if we pop back to our lab guide, that should be our next step. If we go down to next, and we should find ourselves in class 5, module 2, lab 4. So yeah, okay. The first steps it wants us to go through is simply to visualize what's been configured as the log formats and where it's being pushed to. So let's do that to get a feel of how that actually works. It wants us to SSH into the Docker repo VM, which is essentially where we've been working lately, so we should already be there. And it wants us to be in the home/Ubuntu folder, which likely is where we're at. So I'm just going to pop over to my RDP session, minimize Postman for now. I'm in the Docker host, so that's fine. PWD, and I'm in the right directory. So, oh, come on. Listing the files here. There's two in specific that we want to pay attention to. It's the log default.json here, as well as, where are you? Oh, there, the nginx.conf here. If you remember, when we started the container, we were pulling them in. When we were building the image, we were copying in files as well. So let's have a look at what they actually are. I'm going to cat the log default.json first, and it simply looks like this. So this is my log format, how the output of the logging should happen. And when we look at the nginx.conf file, we'll see two references that is of importance here. Let's see here. Boom, boom, boom. Where are we? Here we go. So the App Protect Security log, first we're pointing it towards the log format, so we define what the logging should look like. And then rather than logging to the local file system, we're logging to a syslog and pointing it to our Elk server. So the Elk server will pick up on all of the logging, and we can have a look at in Kibana to see how that actually works. So if we pop back to the lab guide, we'll see that they want us to access the Elk, and we can do that two ways. We can either do it on the jump host. I prefer to do it out in the browser here, so I'm simply going to jump back to my previous. Let's see if I can get the mouse pointer to show to my previous tab here, and I'm going to go up to the Elk system here on the top. Click the access menu, and click Elk. It'll open up a new tab for me. And come on. And we now have the Kibana in front of us. So what you want to do is under Visualize and Explore Data, you want to click on Dashboard. On the new page that comes up, you want to click Overview here. You'll note that there's one component that's actually broken. This fella here, it's just a GeoIP mapping module that has an API key that has expired. We can disregard that entirely. It doesn't matter for the purposes of what we're doing. Anyways, so this is the simple overview dashboard. Underneath the gRPC module, you'll find the all requests, and you'll see our requests that has been blocked. And for the requests, you can go in and expand and get full information the way that you would be able to see it as well in the Big IP solution about everything that's relevant to this particular attack and its subsequent block, including, of course, the support ID. So you can filter and track the information. Yeah, so you got the support ID here, the one that was generated and displayed on the blocking page for the client. You can, it's perfectly searchable and trackable. You'll get information about why this was blocked, what rule it invoked, and so on and so forth. All of the information about the attack is contained here. And this is just one method of doing it. I mean, there are other alternatives as well. Splunk comes to mind, for instance. Yeah, so any structure that you have in place locally for these things, that's yeah, Elk, Kibana, Datadog, New Relic, whatever, you can achieve the same results through that. And as it matures, the WAF module in Nginx controller will give you the same level of direct access. That's not there yet, though. That's a in the future reference. Cool. Okay, so we see that we actually do get visibility into what we're what's going on and what we're doing. So that's great. The next part is about customizing the WAF policy, because of course so far all we've done is make simple, well, simple in air quotes, protection methods using the default policy set. Now we're going to modify that somewhat, and we're also going to at the same time illustrate the option we have to assign different policies to different parts of the application, as it were. So again, it wants us to go to our Docker repo virtual machine, and we're gonna do some manual labor now. We're gonna create a folder in the home Ubuntu folder called Policy Advanced. I'm just gonna copy that fella out. So popping over into my RDP session, I'm gonna make sure that I am on the Docker system here. And I am indeed in the home Ubuntu folder. So I'm gonna make a directory called Policy Advanced, or ADV there, as it were. Now the lab guide states, hold on. So the lab guide states that we should now create a policy with this content. I'm just going to copy that ahead of time, like so. And we're going to use a Linux-based text editor called VI to create that policy. For those of you that are well familiar with Linux and VI and whatnot, just go ahead and do exactly that. If any of you are less familiar with context-aware text editors in Linux and so on and so forth, you might be better off using another text editor that we have installed onto your system called Nano. It's a non-context aware. I'm not going to explain the difference between the two, but it'll make it easier for you to. There's somebody that isn't on mute. There is somebody that isn't on mute. It would be very helpful if you could mute yourself. Let me see if I can find out who it is.
Someone with the name Alexandros Vafiadis, but this is not the name actually. Because, we have duplicate names.
Okay. Yeah.
I don't have the ability to mute.
Okay, that's a bit.
Can you mute us all?
That's what I'm looking into at the moment. Let's see here. There, maybe. I think the person went on mute now. Cool. Okay, so where were we? We were here. So yeah, I'm going to copy out this. And as I said, if there are those of you that are unfamiliar with VI, VI is a massively powerful text editor with a lot of tools and whatnot. But for those of you not familiar with it, you would probably be better off using Nano, which is also installed on your system. So I'm going to do that just to show those that are familiar with VI would need absolutely no explanation on how to use it. So I'm going to use Nano for those that may not be used to it. So I'm going to use Nano, and I'm going to give it the path of policy advanced, and I'm going to specify a file name of policy underscore base.json, like so. I'll get a text editor opened, and I can simply go ahead and paste in my copied JSON from that I copied from the lab guide. So essentially what we're doing here is we're setting up a modified policy. We're basing ourselves off of the Nginx base policy, which is default base policy. And we're specifying some alterations. Specifically, we're just altering the response pages parameter here. It could be anything. We're going to make another one so we'll look a little bit more at it for our second step. If you're using Nano like me, the fast way to save and exit is to press Control X for exit. Then it'll ask you if you want to save the modified buffer. Just press Y for yes, and then press Enter to accept the suggested file name. So that's Control X, Y, and Enter. Cool. So back in the lab guide, there's a second JSON file or a second policy file that it wants us to create. I'm going to go ahead and copy out the policy in its entirety. Come on, there. Boom. Make sure that you get all the starting and trailing curly braces and whatnot. I'm going to scroll up to the top so I see what file name we're talking about. It's policy mongo linux json.json. Riding horseman at horse. Okay. I'm going to use Nano again, and I'm going to give it the path of policy ADB and the file name of policy _ mongo _ linux. We'll type it correctly. _json.json like so. Did I type it correctly? Shockingly, it seems I did. I'm going to paste in the text that I copied from the lab guide. You see, we're making further alterations to the base policy in this one, specifying that we're specifically looking at certain server technologies. And oh, sorry, of course I can't scroll that way in this one. We can go back and look at it in the lab guide. For now, I'm just going to Control X to exit and yes to save and Enter to save for that file name. I was actually showing you the wrong screen all through that. My apologies. I was over here working, but what I did was exactly the same as the first one. Essentially, I opened up Nano and I pasted in this text and I exited and saved. It's easier to view the text in the lab guide, so let's pop back over there. So yeah, we're making further policy changes in this one versus the first one. We don't have to go into detail of those policy specifications. Is its own topic in altogether. Anyways, we also need to create a new nginx.conf because we need to reference these two files that we have created so far. So I'm going to go ahead and copy the contents of the nginx.conf here in its entirety. And I see from the path here that I'm going to go to the same folder and create an nginx.conf in it. This time I'm going to remember to actually show you what I'm doing. So I'm going to go Nano, and the path would be policy ADB nginx.conf like so. And then I'm going to go ahead and simply paste in my content without that I accidentally typed the character. There we go. In this, you'll see that we have several locations specified, and each of these locations are indeed referencing a specific policy file. Now, we only created 2 different ones, but we could, of course, have created 4 different ones if that was what we wanted to do. The point here is simply that we're specifying different policies for different services here through one and the same Nginx App Protect WAF module. I'm going to Control X and Y and Enter to save and close that. And now we're going to go ahead and spin up a new container image. We're not going to create a new container image. We're going to rely on the same container image that we have. So if we look at Docker PS here, oh, my apologies, I was in the wrong window. Docker PS, come on, there we go. we see that we're basing ourselves on the App Protect and :tc image, and that's perfectly good. That's good enough for the girls I go out with. So I'm gonna go ahead and remove that. So I'm gonna do the docker rm with -f to force the App Protect container. So I'm gonna purge that. Now, I don't need to create a new image because I'm basing myself off of the same image again. But what I'm doing is I'm altering the run command slightly. So going back to the lab guide, it has that here in step 6. The docker run command, I'm going to copy that out like so. And I'm going to pop back over into the RDP session. And I'm going to paste it. You'll see that it's a bit longer than the previous ones. And why is that? Well, it's basically the same, but this time around, we're mounting in volumes several times. So we're mounting in the newly created nginx.conf to its proper location. We're mounting in policy base, which we created, to its appropriate location, and also the policy Mongo Linux JSON into its appropriate location. So it's just the run command that changes, not the image itself. I'm going to go ahead and run that fellow. There we go. And if we give it a second to compile its policies and whatnot, we should be able to see some output here. It's not done yet. But we'll give it a moment. It takes a little while to compile those rules. Now, in a live scenario, obviously you would make sure that the rule set was compiled and whatnot before you retired the pre-existing container, right? So you'd let this one spin up alongside the existing container and then simply flip them over like the flip of a switch. There we go. So what do we have here? Yeah, come on. Yeah, that's fine. All is fine. And we see we have our App Protect up and running. WAF is connected. Fine. Excellent. Cool. Now let's pop over to Edge and have a look at our pages again. So this is in the App Protect one. I'm just going to remove everything after the main component of the URI. And I see that I do get access to the finance application. I'm going to log in for good measure. And indeed, it is here. So I could just quickly prove that we are protected using the same attack type as I've done before, just for good measure again, like so. And we should be blocked, as we are indeed rightfully done, which is beautiful. Cool. So then at this point, what we've done is we've been able to split out what kind of protection that we want for the different elements of our application. So if you remember, we have our base application, which is the overall or the main application, and then we have the files backend, and then we have the app 2 and app 3 taking care of the money transfer and all of these bits. So now we've separated out what policy we want to use to protect these different elements. Okay, let's pop over to the lab guide and progress from there. Now let's have a look at, we're starting to move into CI/CD territory. We're going to use an external reference to make the policy dynamic. And for the purposes of this example, we're just going to look at a custom blocking page rather than the standard one that we've seen several times throughout this node. So if we have a look at the policy that we created earlier, we see that we're altering response pages and so on and so forth. But we want to use an external reference. So we're going to have a look at the GitLab side of things. If you connect to the GitLab directly in the remote host or the RDP session, then you'll have it accessible with its cached credentials and whatnot. So I can just simply go to the tab up here that says GitLab, I can click that fella. It was already opened for us from the get-go. And when I click the username, it'll have cached credentials for me for logging on. This is not public. This is a private GitLab repository. If you remember back to the beginning of this, we saw we had a GitLab virtual machine spun up as part of our workshop. So what we want to do here is we want to go to the project or group here called Nginx App Protect. And first of it, in the first example, we're simply going to look at the reference blocking page. So we see, clicking on that, we see that there's a blocking custom 1.txt. If you click on that, you can have a look at what the HTML looks like. So you know what to look for. The title is custom reject page, and in the body you'll have this is a custom response page, and so on and so forth. So you know what to look for. Excellent. So let's go ahead and make sure that that gets pulled into our base policy. So going back into our terminal and making sure we are on our Docker hosts, I'm going to change that policy base.json that we just created. And I'm going to do so using Nano. Feel free to use VI if you are so inclined. Policy advanced base policy. Oh, sorry, it was policy base .json like so. So what I'm going to go ahead and do is I'm going to leave the majority of it intact, but I'm going to change the response pages elements. So I'm going to remove that entire sub-object. In Nano, if you want to remove an entire line, just put your array on the line and press Control-K, like so. And there we go. And then I'm going to put my array at the end of the enforcement mode line and give myself a line feed. Since I work with YAML a lot in Kubernetes, I'm kind of strict when it comes to indentation. So I'm going to get the same indentation here. Since this is JSON, white space doesn't matter, luckily, so you don't have to. But what I want here is essentially the elements from the lab guide. I'm going to go ahead and copy that to just make it a little bit more efficient, ensuring that I'm not mistyping all the way. So I'm just copying out the response page reference element here. Popping back into the RDP session, I'm just going to go ahead and paste that there. There we go. And I'm going to add myself one white space because I'm quite OCD about these things. Excellent. So we see now that we're linking to an external reference for our blocking page rather than just using the defaults. So that's excellent. We can go ahead and save this again in Nano. Control X to exit, yes for saving, and enter to accept the file name. It's beautiful. So now we've made the change. Does that mean that it's immediately reflected? No, it isn't. In order for it to be reflected, we need to make sure that it's pulled in. Now, since this this is mounted in as a volume. Okay, as a matter of fact, I think all that is required now to reflect this change. The lab guide will ask us to respin up a container in its entirety. I don't think we have to. And the reason I don't think we have to is because I'm just going to copy the docker run command that the lab guide suggests to us to run and paste it here. The reason I don't think we need to is the files in question. The file we have touched now is this policy-base.json, right? It's mounted in as a volume, which means that any change that I have made to that file on my Docker host is immediately reflected in the file within the Docker container. That in turn means I don't think we need to remove the container at all. I think we can simply reload the configuration in that one. So let's try that on for size. Docker exec, and it's in the App Protect container, and what we want to run is nginx-s reload, like so. Very, very conveniently. I believe that should do the trick for us. Let's let's fly without a net there for a second and see how that works. Okay, so the good news is the signal process has started. Let's verify if I try to make an attack now on my our App Protect Arcadia side of things. Let's see if we're actually getting an updated page. So I'm gonna give it, well, the same. Same attack as always. And indeed, there it is, our custom magic updated custom response page pulled in from an external resource, not specified locally on the system itself. Now, this was just a custom response page. It could just as easily have been a policy file. I mean, it makes no difference. A file is a file is a file. That's the beauty of having a Linux-based software solution. It makes it incredibly flexible to design the solution exactly the way that you want. Now, jumping back over into our lab guide, we're actually going to bypass a segment here because it doesn't really teach us anything new. But we'll talk about it quickly to just cover it anyways. The next step of this particular app guide is to create the OWASP top 10 policy for now. And it's not doing anything different than what we've already done. What we're doing is we're creating a new JSON file containing the template for the OWASP top 10. And feel free to read through this on your own time afterwards. I just want to make sure that we get as close to the 100 mark as we wanted to at the end of this. It's not doing anything different than what we've already done, except for it's pulling in the OWASP top 10 rule sets. Feel free to copy this one out. It's actually handy to have on hand, the JSON file. And then we are simply spinning it up on the basis of that, pointing towards the policy in the same way that we did for the different policies that we just did. So it's not really adding anything to our learning curve. So in the interest of time, we're just going to bypass that one for now. So we can go ahead and click next, which should lead us to class 5 module 2 lab 6. So what we want to do now is deploy NAP with the CI/CD toolchain. So this is where it gets really interesting, because now we're going to automate everything we've done so far and make it run in an automated fashion. So what we're going to end up doing is we're going to simulate that a new signature file became available. And on the basis of the availability of the updated signature file, the CI/CD toolchain will kickstart a workflow and create a new Docker image. So you see there are 3 stages to our automation here. It'll build an updated Docker image, which we did manually 3 times earlier. It'll push that image to the registry, and then it'll run Docker to discard the existing container and start a new one. And it'll do all of these steps in an automated fashion. So in essence, by doing step 8, we're automating everything that we've done so far in this lab. Cool. So how do we go about that then? Well, we want to go back into our GitLab in our browser, and it's probably best if I just guide you on the RDP session. So I'll be your guiding hands here. We'll go back to the GitLab tab, which for me was the second one here. And I'll just, I'll go out to the Nginx App Protect here element. So my URL reads 117 Nginx App Protect. Cool. So what we want to do is to do the Docker signature element. So the NAP Docker signature side of things here. It's all been pre-created for us, the automation chains and whatnot. It's all been put in place for us. So the next step to avail of all of these things. You see the repository contains everything that that we were dealing with earlier, the entry point.sh, the certificate and the key, the log file, the Nginx conf, and playbooks and so on. So it contains everything that we were dealing with when we were creating the Docker images manually through the Docker build command. Now we're going to make sure that it gets automated. So we can start by just verifying real quick what's the current signature. I think it was yesterday's date, but we can have a look real quick. I'm just going to pop over to my terminal, and I'm going to jump over to the CI/CD server. On the CI/CD server, I'm going to run a yum command, notably info. And what I want info on is the app protect. No, that was attack dash signatures, like so. Yep. Okay. And I see that we have a timestamp for it. Where are we now? There, version. So yes, indeed, it was yesterday, 2021-04-07. Now, what would happen in a proper production environment with this automation tool chain is you'd simply, when you detect a new signature availability, which you can do via a webhook or anything of that nature, you would trigger this workflow, and it'll automatically create a new image, a new base image for your Nginx App Protect container, and probably you're just going to use this timestamp as your tag to indicate what signature base you're coming into. Anyways, so that's exactly how the GitLab's part is set up. So what we're going to do to trigger this is we're going to simulate that a new threat campaign package became available. So I'm going to go back to my GitLab's page. And so long as I'm in the right place, I'm in the App Protect Docker signature part of things, I'm going to have a look at the, where are we? There we go. This text is so small, I had a hard time reading it. The repository here, I'm going to have a look at my tags. There's probably just going to be one there. Yeah, indeed. So that's an older one, but I'm going to create a new tag, and that'll kickstart the entire process. Now, I'm creating this tag manually. This would obviously be happening automatically on the basis of a webhook or something of that nature. So I'm just going to call this tag Leif, because it doesn't matter what the tag is, and nothing could possibly matter less than Leif. So I'm going to create that tag as such. So the tag has been created. If I go and have a look now in the CI/CD pipelines, I should probably have one in a pending state. It's already popped into running, so that's good. I can click on it and have a look at what's going on. And we remember that we were seeing 3 stages, right? We have the build image stage, we have the push image stage, and we have the run Docker stage. This is actually going to take a few minutes, because if you remember when we created the Docker images, it's going to take about 3 minutes to run through it completely. But essentially what we're looking to have happen here is, once this has completed, that went awfully fast, I think. But maybe it's just maybe I happen to get a tremendous amount of bandwidth or something. Let's have a look-see. What I'm hoping to see have happened now in my terminal is, if I do, I'll make sure that I am on the Docker host first and foremost, and I'll do Docker images. I was hoping to see a 4th one there. Let's see here. Docker PS. I'm really fat fingering this now. Docker PS. Okay, it has indeed spun up the new container, but for whatever reason, And we see that it's basing itself off of a different repository, and it has the updated tag and whatnot. Yes, of course. Now it makes all sense. Makes sense to me. And what confused me was when I ran Docker images here, and hopefully it did it correctly. What confused me was I didn't see the updated App Protect container image, which is of course true because it's not pushing it into this registry. It's pushing it into this registry. So it has indeed happened. It's just on a registry on the GitLab's server rather than on the Docker host server. And that confused me for a second. So everything is as it's supposed to be. And it did indeed create a Docker image. And it did indeed, as we see, spin up the updated image with the updated tag. So that entire toolchain automated everything we've done so far and did it in a matter of minutes, which is pretty cool. I'm sure you'll agree. Cool. We've gone ahead and done that. Let me just see where we're at. Yeah. Cool. So I'm in the lab guide right now just to show you where we are. So how are we on time? We still have a little bit, don't we? Yeah, about half an hour. I'm just trying to think of what's most useful for us to cover. Yeah, we have time. So let's go ahead and continue with module 3, protect Arcadia with Nginx App Protect in a Linux host. So what we're going to do now is instead of utilizing a Docker container, we're going to utilize a fully fledged VM, as it were, in our example, but it might as well be a standalone box, whatever the case may be. So we're going to have a look at how it would be, how the process would be to deploy Nginx Plus and App Protect packages manually rather than through the semi-automated and fully automated methods that we've done so far. Depending on how fast we do this, we might as well auto-deploy the exact same thing through the CI/CD pipeline, but it's precisely the same maneuver as we just did, so we might skip that to get to the next step. We'll see. Anyways, let's start by next. So we should be in class 5, module 3, lab 1 here. Now what it wants us to do is to SSH into specifically the App Protect in CentOS host, which is .10 here. We've done .8 and .12 so far. So I'm just going to copy this command here, like so. And I'm going to pop over to my RDP session. In my terminal, I'm going to create myself an additional tab by clicking the plus here. I'm also going to go ahead and rename that directly and call that CentOS, like so. So I know where I'm at. Then I'm going to paste the SSH command like so. And I am now inside my container, which is excellent. If we remember from the lab guide, what we want to do first and foremost is to get the repository reference. We're doing that by simply running a wget command. I'll copy that in its entirety. And I'm going to go ahead and paste it here. There we go. So wget is simply fetching this file from a URL and saving it into a file locally. So I'll go ahead there, and it did indeed receive the file. All is good. Then the next step for us, a couple of things just to note before we go through to the next step. We would have already populated this CentOS machine with the certificate and the key, so that's already in place. Otherwise, you would have to do that yourself, but it's just two normal files, 2 text files that needs to be put into a directory. So on the basis of us having pre-populated that, we can go to the next step of the lab guide directly and simply run the install of App Protect with the -y to just enforce yes for any queries. And as we learned earlier, the package manager will take care of installing Nginx Plus for us because it's a prerequisite for the App Protect package. So let's go ahead and run this fella. This will take a few moments, of course. Installing Nginx Plus in itself is actually super quick. It takes a matter of seconds because the binary for Nginx Plus is, would you believe, 3 megabytes. The bulk of what we're pulling down here and deploying, and there we go, we're done already, is the App Protect packages, because it has so many different functionalities and different libraries, not least of which that it itself relies on. That's the bulk of the size of what we're pulling down in terms of storage. Excellent. So let's have a look and see if Nginx has been deployed. So I'm going to run Nginx-v for a version. And indeed, it has installed Nginx Plus, specifically version R2023, which is the current one. Okay, let's go ahead and have a look at the configuration file as well of Nginx here. So we can just change our working directory into the appropriate one, which is /etc/Nginx. If you worked with Nginx at all, you'll be well familiar with what exists in that. What is notable for us is this PAL here called nginx.conf. Again, the lab guide is utilizing VI for all of these things. If you're unfamiliar with it, you can follow along with me instead. So I'm going to simply rename the nginx.conf to nginx.conf.old so I can create my own one. And I'm doing that via mv or move nginx.conf to nginx.conf.old, like so. I'll have to sudo that first. Sudo. In case you're wondering, my favorite hobby is to forget to put sudo in front of commands. So I've now moved that file. If I verify that, we see that the nginx.conf is indeed gone. It's now called nginx.conf.old. So that leaves me open to create a new one. So going back to the lab guide here, and again, the lab guide wants us to use VI. I'm going to use Nano to run alongside with you guys that may be unfamiliar with it. I'm just going to copy out the entire contents here of the nginx.conf, starting with user nginx and going all the way down to the last curly brace there. I'm copying that and popping back into my RDP session. I'm going to nano nginx.conf like so. And then I'm going to simply paste in the content that I just copied. Boom, boom, boom. And if we remember to exit and save, it's Control X, press Y to save the buffer, and enter to accept the file name. We're also going to create the log default.json. So popping back to the lab guide, I'm just going to copy out. It's not that much, but it saves me typing, and that's always a good thing. I'm going to copy that. I'm going to nano that as well in the... my mistake. Did I mention what my favorite hobby was, ladies and gentlemen? When I tried writing this file, it said permission denied because I forgot to sudo. So I'm just going to Control X and N here. And I'm going to have to do this again, but this time perhaps let's try for good measure with sudo in front of it. I've gone ahead and copied the previous, the Nginx again part. I'm just going to put that in there. It's really embarrassing how often I forget sudo. So Control X and Y and enter, and that worked a lot better. Now, we were also going to create the log default, so I'm going to go ahead blindly in the background. I'm copying out the content from the lab guide, and I'm going to go ahead and, would you believe I almost did it without sudo again, just seconds later. There we go. And the file we're creating now is underscore default.json. Like so. And I'm going to paste in the content that I recently copied blindly from the lab guide, which looks like this. Control X, Y, and enter to save, and all is good. This is a kind of an important step in the lab guide, the next one. It's important to note because this is not how we would do it in a live scenario. You would generally not just simply disable SE Linux globally. You would set up specific rules for what SE Linux should let through it, and so on and so forth. Here we are just putting it into a permissive state globally for the simplicity of it. This is, again, I reiterate, not the way you would do it in a production environment. You would specifically add rules for what you want to have happen. But that's what we want to do. And subsequently, we're going to start the enable and start the Nginx service. And that is all that's needed to start, or rather deploy Nginx App Protect on a base Linux machine, in this case, CentOS. I'm popping back over to my RDP session. And I'm gonna disable SE Linux. And then I'm just copying the commands out from the lab guide in the background. No need for me to jump back and forth for you guys just to see that I'm copying stuff. And I'm pasting them in here. So these two commands, first I enabled the Nginx service, so it'll start on every system restart, and then I'm manually starting it for the current session. And it may very well be that Nginx was already up and running. So let's see. Okay. Process exited with code. Okay, let's have a look, see what it was allergic to. I might have a typo somewhere because I actually typed some things manually. Nope, that's not what I wanted. I forgot I'm actually in a Windows terminal, so I can't just enter to copy. I need to Control C. There we go. That's more like it. So let's see here. Failure to read. Okay, so I probably have a typo either in a file name or in a path here, I would imagine. So it's likely failing to line number 33. Fail to read log default.json. Let's see here. It's always handy when something doesn't go exactly as planned. It proves that we're actually doing this stuff live. I'm guessing, yeah, so I have an underscore where I should have added dash. There we go. Sudo mv log default to log default, like so, and there we go. And that should fix that problem. If I now go and start Nginx, we should have a better outcome. Yeah, so this looks good. It's doing the compilation off of the rule sets and whatnot. So in a few seconds, it'll come up and say, yeah, that. So what we can do now is we can have a look at the error log. So, and the error log is in /var/log/nginx, and it's error.log. So let's see here. Yeah, it's all fine, running, up and running. We're of course now in the same problem as we were in the first Docker image. We didn't install the threat campaign, updated signatures, nor did we install threat campaigns. But we know all we need to do to make that happen is to add a second repository and also add the appropriate install parameters, exactly the same way as we did it in the Docker. So there's no point in us spending time going through that as well. So just to prove our point here, I'm going to pop back over into my Edge browser, and I'm going to use one of the other bookmarks, notably Arcadian App CentOS. I'll open that fella in a new tab. And we see that we are now going through the CentOS machine, and we should be protected just fine, even though we are on older signatures. Like so, and indeed we are protected. Excellent. So going back to the lab guide, we're going to skip these steps because we've done them already in the Docker side of things, and there's zero difference in doing it manually. All we would have to do to add the signatures is to add the second repository and do the installation of the App Protect attack signatures, exactly the same way as we did it in the Docker container itself. And then it's likely it'll do the threat campaign bit as well, which again is exactly the same. We're also just making sure to install the App Protect threat campaigns package. So you see there's zero difference in the approach here, whether you're going through a Docker container or a VM or a bare metal machine, whatever. Exactly the same method in place. So it makes it beautiful in terms of automation and stuff of that nature, because you don't really care where it's running. All you care is what you want to have running. In the interest of time, we're going to skip those ones because we've done them 3 times already. We might skip this one as well because the next one is quite interesting, actually. This is just a matter of doing exactly the same as we did for the Docker container, but via CI/CD pipeline. So it would automate the install of it on a fully fledged machine rather than on the in a Docker container. I think we'll skip that one and rather go to the next step because we've already done all of this. Feel free to do these steps. There's nothing wrong with going back and doing these steps later if you want to. The lab will be running for several hours after we're done. I know there's this distinct possibility that you won't have time to do that. You have lives and work and whatnot, but the possibility exists if you have time. Anyways, so yeah, we'll pop on over to. There we go. This functions really, really well as our final full module. So we want to be in class 5, module 4 specifically. We're going to protect Arcadia now directly in the Kubernetes Ingress Controller. Rather than putting protection in front of the Kubernetes Ingress Controller, we're now going to include it directly in the controller itself. So let's go ahead and run through that. What we're going to do now is we're going to move the protection tier here into the ingress controllers themselves. So it'll look like this instead. We're essentially eliminating the tier in front of it and putting it directly onto the ingress controller. So what we want to do here now is we're going to deploy the new version of the pod, and we're going to add the configuration template. So essentially the YAML to ensure that we also include protection. This is all happening on the back of custom resource annotations in Kubernetes. So again, fully automatable and fully orchestratable. So yeah, Live Guide wants us to go to the Arcadia Kubernetes, which is the direct access. I'm going to do that just to illustrate what's going on right now. So that would have been this one, I think. Let me see. I think, yes. So that's the going directly through the Kubernetes Ingress Controller. Now, what happens here then if I try to do an attack? Nothing happens. And the reason nothing happens is we have no protection here. This is just a simple Kubernetes Ingress Controller, which we created as step 2 in the workshop today. So we're going to fix that. And the way to do that is we're going to go over into the CI/CD server in our terminal. So I'm going to pop into the terminal here, make sure that I'm on the CI/CD server here. And I'm going to delete the existing Kubernetes Ingress Controller first and foremost. We go to the lab guide, you'll see that that command is outlined here in the steps for step 2. So I'm going to go ahead and copy out this command. Now it's important to note everything here is declarative. So when I pop back to the RDP session. So I'm going to run this command. So, and now instead of applying this file, I'm now going to delete, but I'm still giving it the same file. This is exactly the same file as we, at the very beginning of this workshop, did the kubectl apply for. Now it's going to use that same file to make sure that it cleans house completely. It cleans up everything that we applied when we applied it originally. So I'm just going to go ahead and run that. It should only take a few seconds. There we go. And now we're gonna go ahead and pull a new Ingress controller image and deploy it. So I definitely recommend copying this command from the lab guide rather than trying to point it out to write it out. So we're going to do a Helm install here. So we're using Helm for this deployment. I'm copying that in its entirety, and I'm popping back over to my RDP session and pasting it. So you see that it's installing some basic components, but it's also setting some environmental variables that's being used throughout this, namespaces and yeah, things that you are familiar with from Kubernetes. If you're familiar with Kubernetes, it's nothing different, nothing new. I'm not going to go through them in individually, but we're simply going to go ahead and run this fella. So we're getting a number of warnings again for the for things that will be deprecated and whatnot. But success, the Nginx Ingress Controller has been installed. So that's all good. Now we're going to apply a couple of YAML files through kubectl. It's in order to create the policy files and so on and so forth. So you can copy them as well from the lab guide, popping back here. So under what we copied just now, you have these two fellows here. You can copy them individually or you can copy them together, however you choose. I'm going to run these two commands, which will create the policy and also deploy our new Kubernetes Ingress Controller, this time with App Protect as part of the package. So let's pop over to our Edge browser again, just to have a look in the Kubernetes dashboard and see how things are looking now. So if we go and have a look at towards the bottom, I think, no, okay, so. Oh, come on, respond. There we go, replica sets. Let's go around this thing. I'm just going to go ahead and refresh here because everything was lagging so much. I'm fearing I'm sitting on some old information here. Yeah. There we go. Got all my pods running. Now let's have a look, see what happens if we're trying to attack our system. Now I have so many tabs, I have to keep my wits about me. Which one was the one? This one here. So I'm gonna try without the attack first, just to see that it's actually running. Oh, I'm getting a bad date. Okay, yeah, I should have mentioned this at the beginning. There were a bug in the lab. I was sure they would have fixed it all the way, but I think I know what it is. So give me a second. I just want to go ahead and have a look here in what we did here for the Ingress controller. The Ingress controller is likely pointing at the wrong DNS, I imagine. So cat the K8s. It doesn't really matter. All that we're going to show is that we're actually blocking it, but I'm guessing that it's the Ingress app.yaml. Just want to see what it's applying here. So this is actually useful. It's the YAML file that we were applying as part, deploying as part of this. Ingress, and it's doing all of that. Nginx. Let's see if I do this. And okay, it was just one folder up. I could have done that easier. It does. It's one out of two things that has happened here. Either the Nginx configuration for the Ingress controller we just deployed contained an outdated configuration that's pointing towards a DNS server that doesn't exist. The other alternative for what the problem here is that it's pulling from since this is a Kubernetes Ingress controller based on Nginx Plus, it's not a public registry it's pulling from. It's a private one, and somebody may have gone and changed the credentials on that. So it's one out of those two problems. Not a big deal. It's perfectly solvable, but I don't want to spend too much time troubleshooting because we only have like 10 minutes left, and there's a couple of things I want to tell you about. Anyways, so deploy policy logs, Ingress, okay, yeah. Okay, so just trust me on that topic. That's the two possible problems that could have occurred here. And I think it's the DNS one. And the reason I think it's the DNS one is because of this bad gateway. So it's essentially trying to resolve internally the upstream, but it's trying to do that by targeting a DNS server that doesn't exist. So that's, of course, fixable. We could have gone in and changed the nginx.conf configuration. Specifically, there's a resolver directive there that's pointing towards a DNS server. If I'm right, it's pointing towards 10.1.1.10 or 11:80, whereas it should have been pointing to 10.1.1.8:53, or actually 53:53. Yeah, 53:53. Anyways, we're going to leave that unsolved. Feel free to play around with that after the fact, but I do want to talk to you briefly about the API security bit before we end off our workshop today. So I'm going to pop back over to my lab guide and go to the API security step. So what I think is vitally important to understand here is that an API endpoint is just an API endpoint. There's nothing magical about it. A web server is, in fact, an API endpoint. Now, there are usually additional headers and additional parts to a workflow that you might utilize when you're talking about APIs, in the sense that they are globally understood to be. And there may be other elements in terms of management as well, such as developer portals and whatnot. But an API endpoint isn't a magical construct. It's just an agreed upon endpoint that exposes a set of features, expects a set of parameters, and it'll do whatever it's designed to do. So the web server, again, as an analog for an API endpoint, the web server expects a URI. Perhaps it expects a number of headers as well, like what HTTP version are we looking at here? Are we expecting or accepting compression, or what's the user agent, and so on and so forth. So it may expect or at least hope for some of these headers, and may issue headers on the response as well, like cache control headers and all of this, and ultimately a response body, which typically would be an HTML file. That differs in 0 ways from any other API endpoint. It expects some input, and it generally generates some output. Not more complicated than that. So from that perspective, we have been protecting APIs all day. That's what we've been doing. We've been protecting a web server, but we've been doing it in a very bird's eye perspective way. So just simply taking into account the entire HTTP stack of layer 7 and just carpet bombing it with protection. You can very, very well use a scalpel rather than the broadsword that we've been using today to protect your APIs. You can specifically protect towards exact schemas So this is exactly how we expect a request to look. It needs to conform to the schema. If it falls any way outside of that schema, this is by default a bad behavior and should be blocked. We don't really have time to go through this. We only have a few minutes left, and I want to leave a couple of seconds for wrap up as well. But I wanted to touch upon it so at least we can see that we can go in and surgically target what we want to protect against. Much in the same way, of course, if you're familiar with the Advanced Web Application Firewall from F5. So feel free to go through these steps. As I said, the lab will be open for quite a while longer. It'll be open for another 5 hours or so, thereabouts. And you'll have access to all of the systems as well as the lab guide. You can't really break anything. All of the Kubernetes commands are declarative, so rerunning commands shouldn't break anything. When you've run a kubectl apply to create something, you can uncreate it very simply by running exactly the same command, but instead of apply, you run delete. For the rest of it, it's very simple. You can't really break anything as such. Other than that, I just want to finalize again by thanking you all for your time. I hope it was useful, that you found some value in it. And we're all available. We're not going anywhere. With my friends in Pylones as well as Nginx and F5, we're not going to disappear anytime soon. So if anything piqued your interest and you need further information on it, whatever the case may be, feel free to reach out to us, and we'll be happy to assist.
So, Liv, thank you very, very much for 3 hours of speaking. And I feel that you really need a beer right now.
Sounds good.
I believe it was very useful with a lot of information. I mean, certainly we can go deeper, but we can speak for 2 weeks and explaining things. But I have the feeling that everybody got an idea of how Nginx App Protect works. There are a lot of questions and debate regarding Nginx App Protect or F5 Advanced WAF. We are here. We are more than willing to discuss it. And as Liv said, it's not a matter of either one of them. Maybe there are cases that you can combine them. There are cases that it's better to choose Big IP. There are cases that it's better to choose Nginx. It's not a binary system. I mean, we have several options.
Absolutely.
So again, thank you all very much for your time, for your patience, and we are looking forward for a next session.
Thank you, Liv. Thank you, Nikos.